So in this video, I'm going to go over the Unit 12 test review. Number 1 says Travis's collection of DVDs contains 14 comedies, 12 dramas, 10 action movies. Find the following probabilities. So event A says randomly selecting 3 comedies without replacing between draws. So if this is without replacing, then we know that this is dependent, so things are going to change. So the very first thing we need to do is add together 14 plus 12 plus 10 and find out how many total videos we have. When we do that, we get a total of 36. So then we're going to talk about how many comedies we have. So the probability of pulling the first comedy is 14 over 36. Now it says I don't replace that comedy. So now I have 13 comedies and 35 left in the bag. So that's 13 over 35. And then when I pull my third one, I only have 12 left in the bag. And I only have 34 videos left in the bag. So on this one, when I multiply across the top, I'm going to multiply 14 times 13 times 12. And then on the bottom, I'm going to multiply 36 times 35 times 34. When I get that, I get 2184 over 42,840. And when I simplify that, I get 13 over 255. So that's my answer. Event B says randomly selecting 3 dramas, replacing between each draw. Now we had 12 dramas, but this time we're replacing. So that means nothing's going to change every time we do this. So we've got 12 over 36 times 12 over 36 times 12 over 36. Again, we can multiply across the top and across the bottom. When we do that, we get 1728 divided by 46,656. And when we reduce that by, again, we're going to get 1 over 27. So event C says randomly selecting 3 action movies, again, without replacing between draws. So that means, again, things are going to reduce as we move along in this problem. So this time we had 10 action movies, so we got 10 over 36. Now, once I take out one of those, I only have 9 left, and I only have 35 videos left in the bag. So that's going to be 9 over 35 times 8 over 34. Again, when I multiply across the top, 10 times 9 times 8, I'm going to get 720 on top. Yeah, 720 on top, and I'm going to get 42,840 on the bottom. When I reduce this, I get 2 over 119. Our last one in this set is randomly selecting 3 movies that are not dramas, replacing between draws. So this time when we talk about which movies are not dramas, we're going to have to add together the 3 that are not dramas. So here's our dramas. So we're going to have to then add 14 to 10. So that's going to be 24. This time again, it says we're replacing. So what we're going to do is 24 over 36 times 24 over 36 times 24 over 36. Again, when we do this, we're going to get 13,824 over 46,656. And when we simplify that, that's going to be 8 over 27. Number 2 says a bag contains hair ribbons for a spirit rally. The bag contains 3 black ribbons and 7 green ribbons. Lila and Jessica are drawing from a bag at random. Explain why the events are dependent, then find indicated probability. Lila selects a black ribbon, and then Jessica just selects a green ribbon. First of all, the ribbons are in a bag. So if we want to talk about why they're dependent, it's because she didn't put it back. Okay. Then we got to figure out how many total. So again, we got 3 and 17 here. So our total number of ribbons is 20. And it asked me initially, Lila selects a black ribbon, and we have 3 black ribbons. So we're going to do 3 over 20. Now, when we take out that black ribbon, we only have 19 left. But we do still have 17 green ribbons, and on the second one, it asked me about a green ribbon. So this is going to be 17 over 19. And the reason why we're multiplying is because of that and statement right there. So we're going to multiply across the top, and when we do that, we get 51. When we multiply across the bottom, we get 380. And that cannot be simplified. So our answer here is 51 over 380. Okay, number 3 says a grab bag contains 7 football cards and 3 basketball cards. An experiment consists of taking one card out of the bag, then selecting another card. What is the probability of selecting a football card and then a basketball card if the first card is not replaced? So if we're not replacing the card, then numbers change. So it says a football card and then a basketball card. So again, we got to add these two numbers together to get our denominator. So we're going to do 7 over 10 because there are 7 football cards. And then if we do not put the card back, then our denominator again here is going to go down. And again, this is going to be an and statement because it says and right here. So we're going to multiply. So we know that the number is going to go down to 9, but we still have 3 basketball cards in there. So this is what we're going to do. 7 over 10 times 3 over 9. When we do that, we get 21 over 90, and this reduces to be 7 over 30. Now the second one says that we are going to replace the card. So this time our denominator is not going to change. So we're going to have 7 over 10 times 3 over 10, because again, we put the card back. So this time we're going to get 21 over 100, and that number cannot be reduced. Number 4 says a teacher asks each student in the class to randomly choose a number from 1 to 90. Write it down. Leon and Mitsugu each write down a number. Find the probability that both students' choices will be greater than 85. Now it doesn't include 85, so it's greater than 85. So we're talking about the numbers 86, 87, 88, 89, and 90. So 86, 87, 88, 89, and 90. So that's 5 numbers. So when we talk about this, what each person writes down doesn't determine what someone else writes down. So this is an independent probability. So we're actually going to multiply 5 over 90 for the first person, and then we're going to multiply 5 over 90 for the second person, because what one person does has nothing to do with what the next person does. So this is going to give us 25 over 8100, and that can be reduced to 1 over 324. So again, when you're trying to think through whether what happens next changes, it really has to do with, if I write something down, does what I write down affect what someone else writes down? And the answer to that is no. So for number 5, it says the table shows that the distribution of male and female students and left and right-handed students in the math club. Make a table of the joint marginal relative frequencies expressed in decimal form. So the very first thing we need to do is add up these numbers. 2 plus 6 plus 35 plus 36. And when we do that, that's 79. So then we're going to divide each of our values, 2 by 79, 35 by 79, 6 by 79, and 36 by 79. When we do that, we get 0.025 here. We get 0.076 here. We get 0.443 here. And we get 0.456 here. Now the way that we get these totals down here is just to add the two together. So here we're going to get 0.101, 0.899. Now we should be able to add those two together and they should equal 1. If they do not, then we know that we have an error somewhere. Then we're going to add our rows. Again, 0.468, 0.532. And again, when I add those two numbers together, they should equal 1. If they do not, then I have an error. Then down here it says, given that a person is left-handed, what is the probability that they are female? So we're looking at our total left-handed here. That's the number we're going to put in our denominator here. So that's going to be 101. And then it's asking us what is the probability that they're females. And so then we're going to put this number over on top. So we're going to divide 0.076 by 0.101, and that gives us 0.05 sorry, 0 point, let's just do this again. This gives us 0.752, which is equal to 75.2%. All right, so the second one says, given that a person is male, what is the probability that they are right-handed? I have no idea why that image is showing up down there. Okay, so that's this one right here, right-handed total. And then it's asking us, what's the probability that they're right-handed? So we're going to then take the 0.443 and put it over the 0.468. So we're going to do 0.443 divided by 0.468. And that's going to be a pretty high number. I got 0.947, which is equal to 94.7%. So number 6 says Joyce asks 50 randomly selected students at her school whether they have one or more brothers or sisters. The table shows the results of Joyce's poll. Make a table of the joint and marginal relative frequencies. So here again, we're going to divide each of these numbers by 50. And we're going to make our table. So here's our table again, dividing 9 by 50, 14 by 50, 13 by 50, and 14 by 50. Recalling that we add these two numbers together right here to get the total down here. Same way here, add these two numbers down here to get the total down here. Add these two numbers left to right to get this total over here. Add 0.26 to 0.28 to get 0.54. Remember again that when we add those things together, they should equal 1, and if they do not, then I've made a mathematical error somewhere. So for number 7, I'm going to draw a Venn diagram to help me solve this problem. And it says, of 60 diners in a restaurant, 15 ordered the fish of the day, 7 are wearing a tie. So I'm going to draw a Venn diagram, and I'm going to do an oval here and an oval here. I'm going to do fish over here on the left, and I'm going to do tie over here. Now let's go ahead and read the problem. It says 15 ordered fish of the day, 7 are wearing a tie. Of the diners who ordered fish, 2 are wearing a tie. So it says of the people that ordered fish, 2 are wearing a tie. So that's the overlap. Now if we want to find how many people ordered fish only, then we would have to do 15 minus that 2. So that's going to equal 13. So that's the number of people that only ordered fish. Over here, we would do 7 minus 2 because we had 7 people that wore the tie. So we're trying to find people who wore the tie only. Again, that's going to equal 5. So to draw our Venn diagram, now if we were trying to figure out how many people didn't do either, we could do 60 minus 20, and I got 20 by adding 3 to 2. That's 15 plus 5. So that would mean 40 people neither wore a tie, nor did they order fish. Okay, so to solve this problem, it says, what's the probability of one of the diners ordered fish or is wearing a tie? Or, this is an or problem. So what we're going to look for is the number of people that ordered fish, that's 15 out of the 60, and we're going to add to it the number of people that ordered that had a tie on, that's 7 out of 60, and then we're going to subtract the overlap, and that's this part right here. So we're going to subtract 2 over 60 for this problem. That's going to give us 15 plus 7 is 22. 22 minus 2 is 20. So that's 20 over 60, which reduces to be 1/3 or 33.3%. So this next set of problems, 8 through 11, first says determine whether the following is mutually exclusive or inclusive, then find the probability. It says here there are 5 nickels and 3 dimes and 5 quarters in your pocket. You randomly pick a coin. Find the probability that it is a nickel or a dime. And remember that U means or. So here, there's no overlap between a nickel and dime. So I can say that this is mutually exclusive. So now I want to figure out how many coins I have in the pocket. So it says 5 nickels, 3 dimes, 5 quarters. So 5 plus 5 is 10, plus another 3 is 13. So our denominator for this problem, and remember when we have mutually exclusive problems or inclusive problems, our denominator is going to be the same throughout the problem until we get to the end. So then it says, what's the probability of a nickel? So there are 5 nickels, so that's 5 over 13. Or a dime. So then we're going to add to it the number of dimes, and we had 3 dimes. So we're just going to add 5 plus 3. Remember, we have a common denominator, so we're not going to change that. 5 plus 3 is 8 over 13. So that is our probability. Number 9 says a jar contains 5 blue marbles numbered 1 to 5. The jar also contains 6 red marbles numbered 1 to 6. You randomly pick a marble. Okay, so the very first thing we need to do first again is to figure out how many marbles are in the bag. So we got 5 blue and 6 red, so that's 5 plus 6, which equals 11. So again, that's going to be our denominator. So then it says, what's the probability of it being red? So we have 6 red marbles, so that's 6 over 11. And then we're going to talk about how many odd marbles do we have. So again, if we think about numbered 1 to 5, we got 1, 3, 5. And then we've also got 1, 3, 5 with the red marbles. So that's a total of 6 marbles again. So we're going to add 6 over the 11 again. Now the question is, do we have some red odd marbles? Now these are our red marbles that are odd. Now how many of those were there? There were 3. So we're going to subtract those 3 over 11 because that's where the two sets of overlap. So we're going to do 6 plus 6, which is 12, minus 3, which is 9. So our answer is 9 over 11. And oh, by the way, this one's inclusive. Sorry about that. Because there is overlap in the two groups. All right, number 10. There are 10 shirts in your closet, 3 blue, 3 green, 4 red. You randomly select one to wear. So again, the probability here is going to be mutually exclusive because I can only choose one shirt at a time. So this is mutually exclusive. Okay, now, again, we got to figure out how many total shirts we have. So we have 3 blue, 3 green, 4 red. So we're going to do 3 plus 3 plus 4. That's 6 plus 4, so that's 10. So again, that's going to be our denominator. So how many of those are blue? So we have 3 blue shirts. Now, again, there's no overlap here in the blue, the green, and the red. So how many, so we're just going to add our other probability because, again, this is an or statement. So how many of them are green? And again, that's 3. So we're going to add our numerators, 3 plus 3, that's 6. Keep our denominator, that's 10. And then this reduces to be 3/5. So that's our answer. Number 11 says a bag contains 6 yellow jerseys numbered 1 to 6. A bag also contains 6 purple jerseys 1 to 6. You randomly pick a jersey. So basically we have a bag that contains how many jerseys? So we got 6 here and 6 here. So we've got 12 jerseys again. So how many of those jerseys were yellow? 6 of them. And again, if they're numbered 1 to 6 and 1 to 6, we've got, and it's asking us about odd here, we've got 1, 3, 5, and then we've got 1, 3, 5 again. So that's 6 again, 6 over 12. Now, how many of those yellow jerseys are odd jerseys? And those were our first set right here, the 1, 3, 5. So that's 3 of them again. So we're going to subtract the 3 over the 12. So 6 plus 6 is 12. 12 minus 3 is 9. So this is going to give us 9 over 12. And again, this reduces because both of them are divisible by 3 to 3/4. So now 12 through 15 says at the beginning of this problem set, determine whether the following event is independent or dependent, then find the probability. If you remember when we talked about independent and dependent, we're talking about whether something is in both groups or whether I replace something or take it out, that kind of thing. So that's what we're going to talk through here. A cooler contains 15 bottles of sports drinks, 5 lemon lime, 5 orange, and 5 fruit flavored. You randomly grab a bottle, then you return the bottle to the cooler, mix up the bottles, and randomly select another bottle. Find whether you pull a lemon lime and a lemon lime. So first of all, we need to add up, again, our numbers here. We got 5, 5, and 5. So we're going to do 5 plus 5 plus 5. So that's 15 total. Now, it also tells us that we return the bottle. So this means this is going to be independent because we returned it and our numbers did not change. So let's say we pull a lemon lime, and I don't like lemon lime, so I put it back. That might be the logic behind a problem like this. So we had 5 lemon limes out of the 15. Now we returned everything, so the numbers don't change at all. So we're going to multiply 5 over 15 times 5 over 15. And the reason this is a multiplication problem is because it's an AND statement. And that's that symbol right there. That's our AND symbol. So we're going to multiply across the top and across the bottom. So when we multiply across the top, we get 25. Multiply across the bottom, we get 225. And when we reduce that, it's going to come down to 1/9. All right, number 13 says a basket contains 6 apples, 6 peaches. Randomly select one piece of fruit and eat it, then you randomly select another piece of fruit. Okay, so again, we got to add our numbers here, 6 and 6. So 6 plus 6 equals 12. So that's going to be our number that we're going to put down here. Now, we're going to start with 12 as our total number in the bag, but it says, what's the probability that I pull an apple? That would be 6 out of 12. Now, I ate the apple, so I'm not putting it back in the bag. So I only have 11 left in the bag. So I'm going to put 11 down here. But I still have 6 peaches in the bag, so that top number does not change. So here again, when we do this problem, we're going to multiply across the top, so that's going to give me 36. We're going to multiply across the bottom, that's 132, and then we're going to reduce that to get our final answer. That's 3 over 11. Number 7, there are 7 nickels and 6 dimes in your pocket. You randomly pick a coin. Oh, by the way, this one was dependent because we ate the piece of fruit and we didn't put it back. Number 14, there are 7 nickels and 6 dimes in your pocket. You randomly pick a coin out of your pocket, place it on the counter. So this is going to be another dependent problem because we didn't put it back. So we again need to figure out how many coins we have. So we have 7 nickels and 6 dimes. So we're going to add 7 plus 6. That's going to give us 13 to start with. So we got 13 coins to start with. It says, what's the probability that it's a dime and a nickel? Excuse me. We have 6 dimes. And then we multiply that and we took it out. So we only have 12 left. But we still have 7 nickels. So this is going to be 7 over 12. So again, when I multiply this, we get 42 because we're multiplying across the top and across the bottom. And then 156. And this again reduces to be 7 over 26. The last problem in this set. A bag contains 8 red marbles and 3 blue marbles. You randomly pick a marble and then return it. So when we return something, this is independent. So again, we got to figure out how many marbles there are in the bag. So we got 8 red and 3 blue. So 8 plus 3 equals 11. So that's what we're going to start with, 11 in the bag. And it says that what's the probability of red and blue? So we had 8 red marbles. And again, we return that first marble we took, and we then still have 11 in the bag. So our 11 is going to stay the same. But now we have 3 blue marbles. So again, we're going to multiply across the top and the bottom. So that's 24 over 121, and that cannot be reduced anymore. 16, 17, and 18 are conditional probability problems. When we talk about these problems, our formula is the probability that A occurred given that B has occurred is equal to the probability of A and B occurring divided by the probability of B. So what we want to do is take the probability of A and B, 2 things occurring, and divide it by the probability of 1 thing occurring. So it says here, a box has green and red apples. 3 apples are drawn without replacement. The probability of selecting a red apple and then a green apple is 0.24. So you notice this and right here. So that tells me I'm going to do the 0.24 on top. Then it says the probability of selecting a green apple on the first draw is 0.43. So that's what I'm going to put on the bottom because that is the individual probability. What is the probability of selecting a red apple on the second draw if the first apple drawn was a green apple? So we're going to divide 0.24 by 0.43. So that's going to give us 0.558, which is equal to 55.8%. Down here on number 17, assume the following events are independent. The probability that a student take the AP Geography is 0.85, and the probability that a student takes the AP Human and Biology is 0.45. What is the probability that a student will take AP Biology given that the student has taken AP Human? So again, we got to find our and one. So the first statement here, the probability the student takes AP Human, that's an individual probability. So I know that's going to go on the bottom. The one on the top, the other one is AP and, y'all see that and word right there? And is 0.45. So that's the one that's going to go on top. So I'm going to divide the 0.45 by the 0.85. That's going to give me 0.529, which is equal to 52.9%. Okay, our last one here. In a neighborhood, 2/3 of the residents vote to plant daisies at the front entrance. 5/8 vote to plant daisies and daffodils. Here's our and one again. So we're going to have 5/8 as our denominator. As our numerator. 5/8 on top. And we're going to divide that by 2/3. And y'all can do this in your calculator. The smartest way to do this is in parentheses. Do 5/8 in parentheses, 5 divided by 8, and then divide that by 2 divided by 3. When you do that, you're going to get 15 over 16 when you reduce it and push math 1, or you might actually just get 0.938, which as you know is 93.8%. So this is another problem that I want to go over from y'all's review. For my students, it was number 19. Some of y'all didn't have this one on there, but I'm going to go over it in this as well. There's going to be a Venn diagram problem on the test. So let's talk about this. It says a group of 44 students who are animal lovers were surveyed to determine which of 3 types of animals they own. The Venn diagram has the results of the survey. It says using the Venn diagram, find the probability of the problems below, and in our case, they're to the right. Okay, so there's 2 types of problems that we're going to deal with when we have Venn diagrams. We're going to have and problems and we're going to have or problems. And I'm going to talk to y'all about the easy way to do and or problems when you have a Venn diagram, okay? So that's what this is going to cover, okay? So in or problems, you can add all the numbers that are in both circles and put that number in the numerator and the total in the denominator. Now, if we were to add up all of these numbers, 10 plus 10 is 20. 9 plus 1 is another 10, so that'd be 30, and 6 plus 2 plus 2 is another 10, so that would be 40. So there were 40, basically, when people responded to the survey, 40 people said they had some sort of animal, right? So how many of the 44 students didn't have an animal at all? That would have been 44 minus 4, 44 minus 40, which would have been 4. So if we were going to put that number, we would have put it right out here because it's not included in these totals here, right? So let's go ahead and move through this problem though. So the first part of this problem asks us, it's an or statement. We're going to go through 3 different or statements and we're going to talk about how to get the totals, okay? So the first problem that it asked for was cat or bird. Now, again, our directions above say that we're going to add all the numbers that are in both circles and we're going to put that over the numerator, which is our top number, and the total in the denominator. So every time we're going to put this 44 in the bottom. But our first problem was cat or bird. So we're talking about everything that's in this circle and this circle. So really all we have to do is add up all of these numbers that are here and then put them over the 44. So when it's an or statement, we're just adding up all our numbers total that are in those 2 circles and we're going to put that over the 44. So what does that mean we're going to do? We're going to do our 10 plus our 10 plus our 6 plus our 2 plus our 2 plus our 1. When we do that, we're going to put that over 44. So when we do that, we get 31. 10 plus 10 is 20, plus another 10 is 30, plus 1 is 31. And then when we divide 31 by 44, we get 0.7045, which is 70.45%. Now our next problem is going to be cat or dog. So we're talking about cats, the green here, or the dogs, okay? So once again, all we have to do is add up all these numbers here and put them over 44. So we can add 10 plus 10 plus 6 plus 2 plus 2 plus 9. So that's going to be 10 and 10 is 20. This is another 10, that's 30, plus 9 is 39. So we're going to put the 39 over the 44. And remember too, sometimes these answers will be reduced fractions, so you guys got to really watch for that too, okay? Put them in the calculator, push math 1 and see if it will reduce. This is 0.8864, which is 88.64%. Now our last one is going to be dog or bird. So we're talking about dog or bird here. So once again, we're going to add up all our numbers and we're going to put those over our total, which was 44 up here. So we're going to add the 1 plus the 10 plus the 2 plus the 2 plus the 9 plus the 6. And that gives us 30. Again, that's 11, 12, 13, 14, 15, and another 15. 15 plus 15 is 30. This one does reduce. Y'all notice that? 30 over 44 does reduce to be 15 over 22. And then that's 0.6818, which, again, when we multiply that by 100, that's what we do, move the decimal place 2 places to the right, then we get 68.18, okay? Now, our next set of problems, we're going to talk about AND statements, okay? So in AND problems, you find the overlapping numbers and add them together and put the number in the numerator and then the total again in the denominator. So we're still going to put this 44 in our denominator, but now we're going to again talk about cats and birds now. So cats and birds, cats and birds. So what we're looking for is just this portion right here, the overlap. So we're going to add the 2 to the 10, that's going to give us 12, and then we're going to put that over our 44. So when it's an AND statement, cats and birds, we're just going to add the numbers that are the overlapping part, and then we're going to put that over our total. So that's going to give us 12 over 44. This one does reduce, again, to 3 over 11. So that's 0.2727, which is 27.27%. All right, our next one is going to be cats and dogs. So cats and dogs. So here again, what are we looking for? We're looking for the overlap because it's an AND statement, okay? So we're going to add the 6 plus the 2. That's going to give us 8, right? 8 over 44. Remember, we're going to put it over the total again. This one also reduces to be 2 over 11. So that's going to be 0.1818, which is going to be 18.18%. Our last one are dogs and birds. Okay, so what is our overlapping number here? You guys should have it by now. You're right, it's 2 plus 2. So that's going to be 4 over 44, which reduces to be 1 over 11, which is 0.0909, which is, when I move that decimal place 2 places to the right, it's 9.09%.